Okay, this is the review sheet for sections 1, 2 through 1, 3. I'm doing this video on request. Okay. 1, 2, 3 is going to go with the first graph, and 4, 5, 6 is going to go with the second graph. Let's see what we got here. We're looking at the limit as x approaches 4. This is a two-sided limit. And there's nothing weird going on at x equals 4, so the limit is simply 4. Number 2, x approaches 8. Something weird is going on. But remember, when we're finding a limit, we don't care what happens at 8, at the limit end. Okay, so we're just looking at what's happening from the left and from the right, and it looks like 6. Number 3, this time something weird is going on again, and the limits are different. And when the limits are different, we say the limit does not exist. Right. When I said limits are different, from the left-hand side, it looks like it's approaching 4. From the right-hand side, it's approaching 2. 4 is not equal to 2. So the left-hand side and the right-hand side limits do not agree. Number 4. X approaches 4. Same thing as number 3. From the left, it's approaching 6. From the right, it's approaching 2. So the limit does not exist. Number 5. X approaches 8. Nothing weird going on there. It's equal to 2. Number 6. X approaches 12. From the left, from the right is the same. So the limit is 6. Number 7. Okay, if I make a mistake on this, just I always screw these up. All I'm doing is plugging it in. Right? 1 plus 2 is 3 plus 4 is 7. Number 8, plug it in, fail. Right? I get 0 in the numerator, 0 in the denominator. So I am going to simplify. So the x is reduced, leaving me x minus 2 in the numerator, x plus 3 in the denominator. That means the limit is negative 2/3. Right? Plug in 0 once the x's are gone. Negative 2 over 3. Okay, number 9. Oh joy, can't do this one in my head. So factor this puppy. What is that? X plus 2, x minus 1, x minus 1, x squared plus x plus 1. Alright, so the x minus 1's cancel, or reduce rather. And I'm going to be left with x plus 2 over x squared plus x plus 1. So I'll plug in the 1, that's going to give me 3 in the numerator, and 1 plus 1 plus 1, 3 in the denominator. So it's 1. Okay. Number 10. Pi over 2. Pi over 2. So secant. I always like to rewrite in terms of others. Rewrite in terms of sine and cosine. Is there a problem at cosine of pi over 2? Yes, there is. Cosine of pi over 2 is 0. So I'm going to 0 on the denominator. Numerator is a number, so this does not exist. Number 11. This is, limit as x approaches 0. Sine x over x times sine x over x. Remember, these two limits there's only one limit here. This limit. You're required to memorize this limit. The limit of this is 1. So it's limit of this is 1, limit of this is 1, so it's 1 times 1, or just 1. Okay, number 12. Right, number 12 is very similar to number 11. What I'm going to do, probably don't need to rewrite it, but the thing is, this part, the argument of sine and the denominator must be identical. So x is not enough down here. That's what I really have. So I'm going to shove a 3 down there. But if I put a 3 down there, I have to compensate it by putting a 3 in the numerator. So this part the sine 3x over 3x, as x goes to 0, that approaches 1. So it becomes 3 times 1, or 3. Okay, I'm going to stop the video.